I'm excited to be at the Open Source Data Summit today. Along with me, I have Balaji, and we are going to talk about scaling and governing Robinhood's data lakehouse. At Robinhood, we use Lakehouse for business-critical applications along with analytics use case. In this talk, we will describe the evolution of big data ecosystem at Robinhood, not only in terms of the scale of data stored and queries made, but also the use cases that it supports. What is a data lakehouse? If you look at it, a lakehouse combines features of data warehouse and data lake. Some of the requirements are things like a data lakehouse must be able to store very high quality data reliably with ACID transaction support. It has to be highly scalable and allow decoupling of compute and storage unit elasticity to support varying use cases. It should be using open data formats to avoid data lock-in. That should be supported with the metadata as well. It should also allow direct access to files, especially for machine learning use cases. For example, you should be able to directly query the S3 prefix or folder where the data is being written. For quick and efficient processing, incremental streaming pipelines must be buildable on top of this data lakehouse. So at Robinhood, we use Apache Hudi as the lakehouse platform, as we were discussing. We are currently storing the raw data using in the Apache Hudi format or the Apache Hudi persistence layer. And we are also migrating all the derived datasets to use the same API. Apache Hudi provides transactional support to data lake tables. It also supports table level locking and supports multiple processing engines such as Spark, Flink, and it does allow us to decouple storage and compute.
And with the Lakehouse, with petabyte of scale of data, we typically have tons of historical data, including personal data, which makes deleting specific users' data a needle in a haystack problem. So the approach we took has three aspects. So first, we masked personally identifiable information for use cases, which needs to honor user deletion request. We keep the mapping between user PII data to mask value protected so that they are in a separate mapping table in a sensitive zone. With the mask approach, the PII data is isolated to it's just a non-sensitive raw zone, and only deletion needs to be applied there. The second aspect is that we employ a masking of the entry layer at the entry layer itself while ingesting the lakehouse. We can have a coherent anonymization strategy which can be implemented centrally by the ingestion team so that the downstream do not have to reinvent the wheel. So finally, we use Apache Hudi, which can perform efficient deletions of these mapping tables without having to rewrite the old table.